So welcome everyone to another Buy Time session. Today we are going to be solving one of the popular machines during the BRCCF, that's Zolar. We are going to look at how we can fully compromise Zolar. So Zolar basically is about directory traversal vulnerability that allows us to read local files. We'll get into that very soon. Let me just share my screen and then we can begin. Guys. Okay. I hope everyone can see my screen. Hello. Any response?
Yeah, we can see your screen.
My network just gave me some small one, but let's do it. Okay. So I'm first going to power on the machine. So in case you don't know, Echoctf is a platform where you can try your hands on vulnerable machines. Okay, so they have free access. You can just spin up some of the boxes and then try them on your own. You also have the paid where you get access to more other boxes and other machines and networks. So you can look it up or you can look at it at your free time. Now, one exciting thing about Echoctf is that like it has this nice tracker where like it constantly updates you on like where you've reached and your achievements and all that. Right. Let me just refresh the page so we get the IP. All right. So now this is the IP of our target system, and as hackers, normally the first thing I would do when we get our IP is we try to see what services are available on that particular machine. So we'll use our favorite Nmap network mapper to run a scan on it. Now, I'm going to do that by typing in this command, then minus VVV for the verbose flag, and then I'm going to name my file zolar.nmap. Now, this can really take some time, so I've already run it. If I do nvim zolar.nmap, you can see that I've already run it. This is not rendering properly. The most important information is over here. So you can see that we have some ports open. We have 22, we have 1024, and then we have 111, 1111, and then so just by looking at the ports that are open, right, we can tell, like we can have a fair idea on what is happening on those ports. We can see that 122 is SSH, right? 1024 looks like an HTTP server because you can see that Nmap tried to send some HTTP requests and then it got some responses. Over here it says HTTP 1.1 and then returned a 500 error. It also sent another one and got this particular error, bad request. Now if you look at 111, it's also tried some HTTP requests and then we see that we have a 200 OK over here, which means that it's possible that we have a web application running on this particular port. So anytime you have a web application, you can just look at it in your browser to see what the web application entails. All right, so I'm going to look at 1111 in my browser. But before that, let's just try 1024 and see what is also there. So 1024, let's see what that gives us. Okay, so it looks like it's a web socket. Now, because I've already tried this box, I played around with this and I realized that there was nothing really interesting over here. Our main focus is 1111. Now, upon visiting 1111, we realized that there's actually a web application running on that particular port. There's a web service on that port. Now, if you look at the page, you realize that the HTML and CSS is not like the HTML and CSS didn't get rendered properly. Now, the reason why that is happening, I'm going to show you shortly. And when I view the page source, right, you realize that it's trying to pull certain elements using a domain name. Now, because the PC doesn't know the domain name, it doesn't know which IP it's maps this particular domain name maps onto. So normally, when you are doing like a DNS request, right, it's the PC first checks your cache, right? and then it checks your host file, and then it also checks DNS, like the local DNS server, before it goes to external DNS servers. So over here, you realize that it's not finding, or zolar.ecoctf.com is not really returning any valid IP address for us. Like if you do the DNS query, we check our cache and then our Etsy host file. Like we are not getting anything. We are not getting any IP address for that particular domain. So it is not able to fetch those items and load them on the page. So to be able to do that, we have to add this particular thing to our host file, and then upon adding it to our host file, I think it should be able to load the CSS and then other things that it has to load. All right, so I'm going to add this to our host file. I'm just going to copy this. Okay, let me just copy this. Then I add it to the host file. Let me just close this. And right now, the Etsy host file is a file that requires root permissions to be able to write to. So that's why I'm using sudo over here. Type in my password. Alright, so I'm going to add it over here. Hope you guys can see. Right. Then I put the IP address over here. Let me just go here and then confirm. Yeah, it looks like it didn't get copied though. Let me see. Okay, it didn't get copied. Let me copy from here. Okay, now I've added to our Etsy host file. I'm going to reload to see if everything gets rendered now.
The 5.
That's time.
You took the 5 along to the host, the remaining. Check the host quality.
Okay, let's see. Okay, so I'm missing the 5, right?
And you have to
Wait.
Let me just do that again. Okay, I think we are
see
good.
there's the 5
In front of the Zolar.
Okay. Right. I think it should work now. So let's reload the page and let's see what happens. Alright, so right now it's trying to resolve the domain, and then it's able to put the CSS files and other files needed to beautify the page. So we can see what the page looks like right now. So normally when you are pen testing an application, like a web application, you normally look around the web application to see what you can exploit over here. Now I've looked at the web application, and then there's nothing really substantial we can exploit over here. All these links. So this is just to change between light and dark mode. I think this is their Twitter link. You can see it's below over here. Then this is their GitHub link. But if you look over here, you can see that the name of the application is AdiDocs, and then it has this documentation page. Let me just open that in a new tab for us to look at it. Alright, so even with that, it's saying 4 page not found. Let's just wait for it to load and see. But while it loads, let's look through this page. Alright. You can keep looking through this page. There's nothing really interesting over here. The website looks static, because if you look at all these links, they don't really go anywhere. You can do directory brute forcing, right? But I've realized that it doesn't really take anything substantial. Normally, what I like to do before even doing directory brute force is to like browse the application itself. Before I even try directory brute force, I want to browse the application itself and see what I can find. So that I just don't make a lot of noise and send a lot of requests. You understand? Because some web applications don't require that you do any extensive directory brute forcing. Right. So after looking at the web application, you can scroll down and you see that it's powered by Netlify, Zolar, and Adidocs. So we can just do some small research about these three things and see what it gives us, right? So you can first look at Netlify. Let's see what Netlify is. Netlify. Can you read about Netlify? It's a remote first cloud computing company that offers development platform that includes build and deploy. That is not really interesting to us right now. Let's look at the second one. Okay, the second one is Zolar. Let's read what Zolar is. Let's see what Zolar is. Okay, we are getting some unrelated search results. Let me just narrow down the search. So this is Zolar application. So I'm also getting some really strange stuff over here. I'm getting Android apps and stuff. All right, so let me just follow the link, right? So there's a link over here that says what getzolar.com. I'm just going to follow the link and see what it's going to tell me about Zolar. Okay, over here you can see that it says your one-stop static site engine. Just by reading this, right, I can infer that this particular Zolar application is used to generate static websites because it says it's your one-stop static site engine, which means it's an engine that is used to generate static sites. Now, if you read further about Zolar, right, on Google and you do a little research about it, you realize that Zolar is used to build static sites, right? So and you know that the app that we have over here is static. Like we don't have really many features over here. The app that we have here is kind of static. So we can say that, or we can assume that this website was built with Zolar, right? You can do some further recon to see to check whether it was actually built with Zolar. But in my experience, like I didn't really find anything specific that showed that the website was built with Zolar apart from those links down there. Now, if you look at the page source, you realize that some of the links or the host name itself has Zolar in it, which means that it's probably the focus of the box, right? Those are just hints for you. Those are just hints for the person that is solving the box. All right. So, as usual, when we are able to identify a particular application, right, or a particular web server that is being used, we can look for vulnerabilities in that particular application. So I'm just going to type Zolar exploits and see what we come up with. And the first result that comes up it says Zolar path traversal vulnerability, and this particular vulnerability was discovered in 2023. All right, so let's just look at it and see what it is. Now, mostly when you are doing stuff, right, you want to really do a lot of recon, right, to even discover the version of the application that we are using. But over here, I think there's not much information about it. I think you can still you can still do some research and recon to find the exact version. But I'm just doing a general search to see if Zolar itself has any vulnerabilities. All right. So it is Zolar affected versions 0.13.0 and 0.17.2. So between 0.13.0 and then less than or equal to 0.70.2 have a path traversal vulnerability. So we have path traversal vulnerability. It says an issue is discovered with Zolar from 0.13.0 through 0.70.2. All right, so the thing is basically, or the vulnerability is basically a path traversal vulnerability. It says the handle request function used by the HTTP server. The handle request function used by the server to process HTTP requests does not account for sequence of special path control characters in the URL, which means that we can actually use this particular control characters, right, to move back or like to traverse the directories. So we are going to try that, right, and just see if the website is vulnerable to what is vulnerable to directory traversal. All right, so I'm going to do that for my terminal, right? We can use WebSuite, but I'm going to do that with Kel because I don't want to start WebSuite now. It will take a while to open up. So I'm just going to use Kel, and then I'm going to paste in the link, and then we'll try the path traversal vulnerability. So as usual, normally when we get the path traversal vulnerability, one of the first things we want to look for or to see if you can read is the etc password file, because it's like one of the files that is world readable. When I say world readable, it means that most users on the PC can read the etc password file. I'm just going to surround this in quotes. Question? Yeah.
Yeah. I just wanted to know if the // doesn't have like specific number of supposed to move before the exit password, or we just go like randomly.
Can you like speak up? I'm not really hearing.
I'm saying that you see when you started doing the // I think you used a number of them, and I'm asking if this is like a static number you are supposed to use, or you just keep trying till you get the exit password, or you just read the file.
Okay. So when normally when you get directory traversal vulnerabilities, you normally, let's say you want to read some particular file on the system, but you don't know where the file is located. What you can do is that you can do as many // as you can, right, till it hits the root directory. Now, when it hits the root directory, you can't go back anymore. So it gets stuck over there. So the number of it doesn't really matter the number of // you do, right? Once it hits the root directory, you've hit the root directory, and then you can write the path to the file that you want to access. Please, did I answer your question? Yeah. So if you do many of them, it will definitely hit the root directory, and then from the root you can start forming your path. So normally when you have directory traversal vulnerabilities, just do a whole lot of // right? It will definitely hit the root. Right, it will definitely hit the root. If it doesn't work, just keep trying till it hits the root. Then from there you can start forming the path to the file that you want to read. Okay, so I just tried that, and you can see that we are able to read the etc password file. And we see that there's this user on it called Zolar, and then we have what /etcctf user. There's SSHD, right? SSHD. All right. So normally when you read the etc password file, right, and you find out that there are different users on the system. Now, one way which you can use to tell whether that particular user has a shell, like you can actually get a shell with that particular user, is by looking at the path over here. So over here, you can see that when you log in as that particular user, this is the kind of shell you get. You get the bin bash, or you get the bash shell, right? It also has the bash shell, and then the rest of them is no login, like a whole lot of other stuff. But when you come to the root side, you see that it's bin bash over here. All right, so now that we know that these two users exist on the system, we can also try to read files inside those particular users directories, right? So I'm going to try Zolar, right? I'm going to try to read Zolar and see if Zolar has an ID RSA file, like has a private key, right? Now over here, I'm approaching the box from a perspective where I know nothing about it. Like, let's see, I'm approaching from a perspective where I'm new to this box and I know nothing about it. That's why I'm trying all this. All right, so if I do .ssh, and I do ID RSA. Let's see what happens. All right, so I don't get anything substantial. It's just basically the website that gets returned to me, which means it didn't work. Which means it didn't work. Probably now, probably because we don't have maybe read access to that particular file. We can try other things and let's see if they work. So we tried Zolar, it didn't work. And let's try ETS CTF and see whether that works. ETS CTF. So we found out there was an ETS CTF user. Oh, I forgot to even add home here. But I still think it wouldn't work because we don't have read access to those files. So let's do .ssh and then let's do ID and see if that works. But it still didn't work. It means that we don't have like read access to that file, so it's not returning anything to us. If I enable the verbose flag on kill, you see what it's returning. It says 403 forbidden, which means that the file exists, but we probably don't have read access to it, right? Right, so let's try to read other files that we might have access to. So I'm assuming that this particular box is being run by the ETS CTF user, right? So we probably have read access to their files. So let's do ETS CTF. And I'm just going to read the bash rc file because that file is constant on everyone's in everyone's home directory, right? So if we're able to read the bash rc file, it means that we can probably look at other files that are in the home directory we can read. Okay, so you can see that we are successfully able to read a bash rc file. This is the content of the bash rc file. There's nothing really interesting over here. But one of the interesting files, right? One of the interesting files we can find under that particular user's directory is the bash history file. Now, the bash history file contains commands that have been tried on the machine by other users, right? Or previously. I'm going to try to read the bash history file and see what we get. Okay, so over here you can see the output over here. Let me just highlight it. I hope you guys can see. Now I'm going to remove the verbose flag so that it doesn't mix up or it doesn't confuse you. All right, so you can see this is the output of the command. So you can see that the person tried to change their user, or the person tried to change the user to Zolar. The person tried to switch the Zolar user. They log in as the Zolar user, and then the person enters the password. But then later on, they tried to stop, like they were entering the password, and they were like, and maybe they realized that maybe they made a mistake, so they wanted to quit the program. But then it looks like the program was still hanging. So those control characters actually got printed in the history. Now you can test that. Let me just test that to my machine and let's see what happens. All right, so you can enter the password. So I'm just trying to switch the maximum user over here. Over here, he tried to switch the Zolar user and then typed in the password. But it looks like there was a problem with the shell that the guy was using. The person, I'm suspecting that there was a problem with the shell that that particular user was using. So when you run that command, the shell was hanging, right? The shell was hanging and he typed in the password and it got logged into the bash history file. But you realize that the password is actually not in full over here. We have what Daniel AYS and then Control C. I don't know whether it's a Control H, but they are just escape characters or they are just bad characters, right? That got added to the original text. So one thing we can do is that we can pick part of the password and check the raw queue. We can pick part of the password, check the raw_queue.txt list and see if we can find the password in there. Now you know that raw queue is like a collection of commonly used passwords. So let's just try our luck and see what happens. So I'm going to cut raw_queue.txt and let's see whether we can find anything like that in it. So raw queue, and I'm going to grab Daniel Lace, right? I'm just going to pick a portion of the password and see if I can find it. All right, we get some very interesting results, right? Now, out of the results over here, you realize that it's this particular password that resembles this a lot. So we'll try this and see whether it works. So I'm going to do SSH, and then the user that the person tried to switch to was the Zolar user. So I'm going to do Zolar at, then the domain name comes echoctf.com, and then I'll copy this password and try to log in with the user's password. All right. So we have initial foothold on the machine. So that worked. Yeah. Any questions? Any questions up to now? Hello? Any questions? If there are no questions, let me know so that I just proceed. All right. So let me just proceed here. All right. So normally when we get initial foothold on the box, right, we want to see, or we want to escalate our privileges to the highest privilege that's on the machine. We are currently the Zolar user. We can check that by typing the who am I command. We can check our groups, the groups that we belong to. You can see that we don't belong to any special group. There are a whole lot of things that we can do to see whether we can get or we can elevate our privilege to the root user. Now, one of the things that you can use to check that is you are checking your sudo privileges on the box, right? Now, sudo is basically an application, right, that allows you to run commands as another user. But normally, when you don't specify the user you want to run a command as, it just defaults to the root user. I'm going to check my sudo privileges and see what I can do with sudo on the box, or which commands I can run with sudo on the box. All right, so you can see that we are able to run with no password. So you can see over here, we're able to run with no password this Zolar application. Now, to know more about this Zolar application, I'm just going to run a file command on it, right, to see whether maybe it's source code or it's actually a binary file. So it looks like this machine doesn't have file on it. I don't cut the file because if I cut it, it will just spit out. Maybe if it's a binary file, it will just spit out raw bytes to me. Okay, I'm just going to pipe it to a pager. Yes, and then let's see what happens. Okay, so it says raw binary. Let's just quickly close this. All right, so it's actually a binary file. It's not really source code. It has already been compiled. All right, so I'm going to do sudo Zolar, and then let's see what happens. I'm going to add the help and see whether it can give me an idea on what that particular thing is. But before I even proceed, you realize that it was Zolar that was being used to as the static site engine that was being used to build the app, right, or to host the app, right. So it could be that that's the same Zolar that we have seen over here. Over here, when you look through, you can see that we can create a new Zolar project. We can build and then we can save. So we can actually create a new website with Zolar and then save it, right? Now it has a series of commands that you can try it with. I've spoken about a few of them. We have init, build, save, check, completion, and help. And then we have various options that we can use with these commands over here. Now, if you want to look further at how you can use these commands, write those commands and then append help. So I can say, I can do something like Zolar build, right? You can say Zolar build help. And you can see for the build command, like there are different switches that we can use with it. Right now, the most interesting one to me here is the save. Now, the save one allows you to be able to spin up like a web server, right? You can spin up your own web server on a particular port, so you can build your own static site on another port, right? So we are going to do that. Now, the reason why I'm doing that is because previously we found that particular Zolar application, right, has a directory to traverse vulnerability. Now, on a Linux system and any other system, right, any user that you use to run a particular application, right, the application runs in the context or the security context of that particular user, right. So if you run an application with if you run an application as the root user, right, the application has root privileges on the system. It runs with root privileges on the system. If you run it as the Zolar uses, it's Zolar user, right? It runs with the Zolar user's permission, or it runs as the Zolar user on that particular system. All right. So what's happening here is that if you are able to save an application, right, with Zolar and it is running as root, we can take advantage of the directory traversal vulnerability to read sensitive files, right? And those sensitive files, we actually get the privilege to read it as the root user. Any questions? Or should I proceed? All right. Now I'm jumping some particular steps that I did because I don't want us to spend too much time on it, right? Under normal circumstances, right, I would actually do a search on this Zolar application and see how to use it before I even go down or before I even use it for anything. So I'm just going to do sudo Zolar and then the command serve, and I'm going to do help to see how we can serve our own web application. All right, so we can specify the interface, we can specify the ports, the output directory, and then base URL and some other ones. But the ones that we are interested in is the interface and the ports, right? Because those are that's what the web application is going to run on. So I'm going to do Zolar serve, then I'm going to specify the interface. So in the interface, I'm going to specify all interfaces, and then with the port, I'm going to specify 1990, right? So now let me use 8989. Okay, perfect. Now let's run it and see whether it starts a server on that particular port. It's okay. We are getting an error. It says that what thread main could not find directory containing config file. So it's looking for some config file. I don't know what the config file contains, but it's probably going to contain maybe certain things about the web application. Probably where the root directory of the web application is and all those things. So if you go back, right, if you go 2 steps backwards and you look in the main root directory, now you realize that there is this directory called Zolar that is owned by the ETS-CTF user, right? So I'm going to go into that directory and then realize that there's this config file over here. I'm going to cut it and see what it contains. So like this is basically a config file for Zolar, so we can use this one. So I'm going to run the command over here, and then it's going to locate that config file and use that to save our application on 8989. All right. Okay, so our web application is up and running, right? Yeah, web application is up and running. We can visit that particular web application. But what we are interested in over here is the ability to be able to traverse directories and then read local files on the system, right? So I'm going to open a new tab. We are going to take advantage of the directory traverse and read some local files, right? And so it should be this is the domain name again. All right. We are currently running on 8989. So I'm going to specify that I'm going to traverse that directories. I'm going to do it as many times as I can till like I hit the root directory. And then I'm going to specify the file that I want to read. So since we are currently running as root, right, it means we can read some very sensitive files, like even the Etsy shadow file. So I'm going to try to read that. And let's see whether it's possible. Okay, so you can see that we've been able to read the Etsy shadow file. um, the root doesn't really have a password specified over here. Over here, but then you can see the password for ETSCCF and Zolar. So you can choose to crack this later on. We have one flag over here. You can choose to crack this particular hash later on, right? But we are actually interested in the root user, and this doesn't really give us a password for the root user or a password hash for the root user. So I'm going to try reading other files on the system. This time under the root users home directory. So as usual, we want to see if the root user has maybe a public key stored in the SSH directory. Then we can use the particular public key to SSH into the machine as the root user. So I'm going to check the SSH directory for the ID RAC key. And let's see what happens. Oh, so you can see that we have been able to read the root user's private key. So we can just copy it, or better still, we can just pipe it to a file, right? Because we have. So I'm going to pipe this to a file. I'm going to call it root.id RAC. Alright, let's start it and see whether everything is intact in it. Okay, it's all intact. I'm going to change the permissions on the file so that we can use that to SSH into the machine, because SSH complains when you set very weak permissions on your key file, because SSH doesn't want a case where other users can, or other users on the system can use your key file to SSH into your servers. So it will force you to like set permissions on your key file, right? So I'm going to do that before that event happens, right? We call the file root.id RAC. Right, so I've set the permission and let's SSH as root into the machine and see whether we're able to log in as root. Right, so I'm going to specify the RAC file, the key file, and oh, voila, we are roots. So I see who am I. We can check. We are currently in the roots home directory. Yeah. So this was the famous Zolar box and how it was supposed to be compromised. Okay, any questions for me? Okay, any questions for me? Hello?
Yeah, Maxim, I can hear you. I don't know if any other person has any question for Maxim, either a question, contribution, or anything that we will
Yes,
come and
contribution.
Okay, so like the place where you use the Zolar to serve something inside the Zolar instance. I actually had a problem just asking that after you did that server stuff like here, where you have your server running on port 8989. Did you do any other thing so that you can access it from your local machine, or immediately you do it, it's exposed?
So you see that when I
running locally.
So you see the thing is that I set the interface to be all interfaces over here. So it's currently running on all interfaces, so it's accessible inside the network that the machine is in. We are currently connected to the VPN, right? So we are inside that particular network the machine is in, and it's being served inside that network, so we can access it.
Thank you.
Yeah. Any other questions? Looks like today we finished on time.
Even early.
Yeah, like
that's because the boss wasn't something that we're blind to. We had idea of what to roam around to find here, there. Now looking for stuff with to go around the whole thing.
Yeah. So for me, one of my challenges with this box was when I had to log in with that SSH password, right? So I was trying to make sense of these bad characters, right? But it wasn't working out. So it was later on that and his was dropped there. Then I just did this rocky thing and I found the password and I SSH into the machine like quickly.
Okay.
Yeah. So it was actually a fun box. I think I really enjoyed it. It actually explains the concept where like any app you run on a particular machine, right? That particular app runs with the privileges of that particular user. So I think in Linux, when you run or when you do your PSAWX, right? PXAUX, right? You can see every single app that is running on the machine and the user it is running as. So let me just do that. Let's see whether the the server we just spun up was actually being run by the roots. So you can see that this is
Yeah.
the command I use, right? And then you can see that it's being run by the root user. And through this, we're able to do the direct traversal and read files on the system. But initially, you can see what the ETS CTF user run. The what we abused initially to read the bash history file, right? This is what the ETS CTF user run. So you can see that he specified the roots as the Zolar directory, and then the config he specified what the config.toml file in the Zolar directory, and then specify the interface base URL zolar.echoctf.com. Yeah. So basically, that's the box. I don't know if you guys have any questions or any contributions, any discussions, any suggestions on maybe the next machine we should solve. Phoenix, I've not heard from you today. Please speak. Phoenix, I've not heard anything from you today. Are you
Yeah,
there?
it was a really
Yeah.
great session, Charlie. I mean, learned something new.
Interesting. All right. So, if no one wants to discuss it, I guess we can call it a day. I'm sure this video is going to be pretty short. All right. So, we can call it a day. We can call it a day. I'll see you guys later.
Okay, Maxim. Bye. Thanks for having
Yeah.
for the evening.
Okay.
Everyone have a good evening.
Can you hear you?